All right, so as you're looking at the first few questions, name the sides that are adjacent to A, which would be angle A. If you don't answer now, it's going to take us a lot longer to get through here, so stop socializing. What sides are adjacent to A? B and C. So which side is opposite angle B?
B.
Side B? What'd you say?
Little b.
Little b, yeah. Identify each angle measure as acute, right, or obtuse, so what's 45 degrees? Acute, that was a toughie, right? And 100? Obtuse. And then 90? Right. All right, so stop. A triangle has a given acute angle, circle its cosine ratio. Yeah, so caught another hippie, right? And then I want you to draw a picture of what they're describing here. A right triangle has one acute angle. So here's our right triangle. It has one acute angle of 53.1 degrees. The length of the side adjacent to this angle is 9 units. Do I put that here? No, what's that? The hypotenuse, so it goes here, right? So the side adjacent is 9 units, and then the side opposite would have to be here, 12 units. The length of the hypotenuse is 15. Circle the ratio of the cosine of 53.1 degrees. Yeah, so it has to be adjacent over that hypotenuse, so 9 over 15 is correct. All right, so that's all review. So let's look at what we're doing today, which is law of cosines. If I don't have the side opposite the angle given, or no ability to find the angle that's across from a side given, then I cannot use the law of sines. So the law of cosines was developed. And so the law of cosines is used with SAS, meaning you have two sides and one included angle. The two sides that create that angle, in other words, SAS would look like this, right? This is your S, and this is your A. So if I have the two sides that include that angle, I do not have the side opposite the angle given. And so in that case, if this were a triangle, I would not be able to use the law of sines. So there's a difference between when do I use the law of cosines and when do I use the law of sines. And if you start off using the law of cosines, do not revert and go use the law of sines. Technically you could, but in several instances you're going to get the wrong answer. So it's better off to stay with the law of cosines once you start there, and stay with the law of sines once you start there. So let's look at what that law of cosines actually is. There's 3 of them. It looks complicated. It really isn't that complicated. What does this look like to you? The Pythagorean theorem. So you got a squared plus b squared, a squared equals b squared plus c squared. So whatever side you're trying to find is over here. So whatever side you're missing is over here. And then the other two sides are being added together as squares. And then you subtract from that, whatever these two sides are here, that's what gets multiplied to 2. And then the cosine of the side you're trying to find is here. I am not giving you these formulas. You have to know the pattern of the formula. It's a simple study thing. And you're either going to determine to study it or not. The law of sines is really simple, wasn't it? The law of cosines is a smidgy bit more difficult. But all you have to do is look at it and go, okay, this is the side I'm finding. The angle's on the opposite side of the same side that I'm finding. And then the two other sides, I just square them, think Pythagorean's theorem, and then don't forget you have a minus 2 times whatever those two sides are. And so on number 6, I want you to circle the equation that's true for angle DEF. So let's see which one of these that they did correctly. So if I'm finding side D, I would have the other two sides squared and added together. So far that looks good. Then subtract 2 times, shouldn't it be these two? Is that what they did here? Nope. So that one's out. Put a line through that one. So if I'm trying to find f, then the other two sides are being added together here squared, so that's good. Are these the two sides that are here? Yep, so far so good, and we have a -2. And then is this the angle of the side I'm trying to find? The angle across on the side I'm trying to find? Yes, so this is a good equation. Let's just look at the last one for chuckles' sake. So again, here's the side I'm trying to find, E. D and F are the other two sides being squared and multiplied. We have a minus, what's missing here? 2. Everything else was perfect, but they missed the 2, right? So if they had put a 2 in here, we would have been okay. But that one is not correct either. So that's all you're doing. It doesn't matter whether it's A, B, C, D, E, F, G, A. It doesn't matter what the letters are. You're thinking pattern when it comes to law of cosines.
Why wasn't the first one wrong?
The first one was wrong because the DE right here, and so you might want to put right underneath here, the DE right here was not the same as the F and the E that were here. So whatever these two sides are here, those have to be the same over here. Does that make sense? Okay. So then let's look at example 1. So in triangle LMN, they give you angle L. Right here is 104 degrees, and then side LM right here is 48, and side LN is 29. Oftentimes they're not going to draw a picture. You have to draw your own picture. And so isn't this S, A, S? I do not have the side opposite the angle given. I cannot use the law of sines. And so I must use the law of cosines. So then they want you to label the sides of the triangle with the little lowercase letters L, M, and N. So what goes here with the 48? Little case n. What goes across from the 104? L. And what goes across from, what goes next to the 29? Lowercase m. And so I'm not going to necessarily go through all of this stuff here. You can read it and put it in there if you want to, but we're going to create our equation down here. So based upon what I'm trying to find, they want you to find mn. Well, isn't mn side L? Because it's across from angle L. So if I'm trying to find L, I want L squared on one side by itself. Aren't the other two sides m and n? So I'm going to put m squared and n squared. And then it's always -2. And then what goes in these two slots here? The m and the n, the same ones that are here, go here. So I've got m times n. And then of course we have the same cosine of the angle that we're trying to find the side to. And so we're just going to fill in what we know. So I don't know L, but I do know that M is 29. And I know that N is 48. And again, the 29 and the 48 get repeated. And then the cosine of angle 104 degrees there. And so we're going to run that through our calculator. And it might take you several steps. And so on your calculator, do not round. So use the whole thing. You might actually round when you write it on the paper, but not in your calculator. So when you use, and those of you who are looking at the video aren't going to be able to see this. But the rest of you, I want you to take the yellow graphing calculators. And I'm going to switch my display. All right. So here you go. So you're going to take 29 squared and hit, see the squared button right here? It's 4 buttons below your second key. So hit that x squared button and it squares that 29. And then plus 48 squared. So hit that squared button again. -2 parentheses 29 end parentheses begin parentheses 48 end parentheses. And then we have times the cosine of 104. You can press times if you want to, or you don't have to, because it will know that if it's smack next to it that it's multiplying. And then we've got cosine of 104 degrees. And get in the habit of ending those parentheses and then hit enter. Wow, that's huge. Why do you think? Right. So we end up with a very large number, which for the video purposes, let me just put something on here. 29 squared. So this was 841 plus 48 squared was 2304 minus 2 times 29 times 48. 2784 cosine of 104. All right, so then we ended up with 38, 18, don't round, point, and a really long decimal, 510557, dot, dot, dot. All right, so I want to take the square root of this. Do you know how we're going to do it? So look above the x squared key. Isn't there a square root above there? And it's in blue. So how do you get to the blue? So second function, square root. You should see a square root with a parentheses. I want to get this answer into that square root, so you're going to hit second answer, which is the negative key down here. So hit second answer, and then get in the habit of ending those parentheses. Now hit enter. Does that seem more reasonable? So when you take the square root of 38.6, you get about 61.7940 dot, dot, dot. All right, so now I'm going to switch back. All right, so if I'm going to round that to the nearest, do they say where to round to? No, nearest 10. So what is this rounded to the nearest 10th if I want to round here? Yeah, because of the 9, we get 61.8 units for that answer. And that's right in along the line with the rest of those. Well, I don't know why we're packing up. Let's go to the second page or the next page. All right, so problem 2. This time we're using SSS. So not only can we use law of cosines with SAS, but we can use it with SAS because as you look at this picture here, do I have any angles across from any of the sides? I can't use law of sines if I don't have an angle. So therefore we're going to use law of cosines. And then you decide what you want to find. In this question it says find the measure of angle T to the nearest 10th. Well, here's angle T right here. So if that's the angle that I want to find, then I want to make sure that I'm using T squared, right? So we're going to do T squared equals, what are the other side names? What are the other angle names? U and V. So we've got U squared, V squared, minus 2UV times the cosine of what angle? Angle T, capital T, because my side length is T squared. So if I'm finding that, and then we're obviously going to have to solve this equation for the cosine of T, but that's okay. So we've got, we're going to plug in what we know. So I know that what's across from angle T? So 7.1 is going to be squared. And then what's across from angle U? 6.7. And then what's across from angle V? 4.4. And then I've got 6.7 here and 4.4 here. And so when we square 7.1, we get 50.41. And 6.7 squared is 44.89. And 4.4 squared is 19.36. And then 2 times 6.7 times 4.4 is 58.96. I have not rounded yet. Times the cosine of, and I'm not going to put the angle in there, so times the cosine of T, capital T. So then, can't we add together these two, following their math? So the 44.89 plus the 19.36 is equal to 64.25. We still have the 58.96, and we still have the 50.41. And then here, can't we, I don't like the way they show this, but can't I can't I subtract the 64.25 from both sides? So we have the 50.41 minus the 64.25 equals the negative 58.96 cosine of t. And then they skipped a step, didn't they? So we're going to put out here what the step that they skipped. So 50.41 minus 64.25 is negative 13.84 equals negative 0.96 cosine of t. Now how'd they get what they have over here? And now how'd they get this? Yeah, they're going to divide both sides by negative 58.96. And so we get,
Why is 58.96
because there was a negative 2 in front of it originally, so that negative stays with it, right? All right, and so we get and this is rounded, but you're not going to round it in your calculator. So we've got 0.2347. And then on your calculator, how are we going to, and you can see here, well, they were telling you to do the inverse cosine. So aren't you going to do second cosine? And then how do you get that answer? This full answer that's in your calculator, not this little bitty one, but the full answer. How do you get that in your calculator? Nope. So we already did second cosine, but we want to do second answer, right? So then do second answer, and in those parentheses, what'd you get? Do second cosine, and then second answer, which is above the negative. What'd you get?
76.42.
Yeah, you should have 76, and we're going to the nearest tenth, right? 76.4, and that's in degrees. Do you need to see that in my calculator? Yes, no? So again, here, all I did was I took this negative 13.84, divided it by the negative 58.96, and I got that answer. Then you're going to do second cosine, and then second answer right down here, and then hit enter. Okay? All right, so then I want you, I guess we'll finish problem 3 tomorrow. That's fine. It's just a word problem, but we've gone over the law of cosines. All right, so let's just recap this problem that we had from yesterday, because I know that some of you were struggling on your homework a little bit. So look at all of this work that we did here. So if you're given the 3 sides, and let's look back up here. If you're given just 3 sides, as you were here, this is the problem that requires the more difficult work, I would say. So you've got to get in the habit of writing out your general formula, because every triangle is labeled differently. A, B, C, D, E, F, in this case, T, U, V. And so since we were trying to find angle V, we're finding angle T, right? Since we're finding angle T, we wanted to put its side that's opposite angle T, which is side T, on one side by itself. And so this is just a pattern. So T squared equals the other 2 sides, U and V squared, added together. Then minus 2 times the same 2 sides you have here get multiplied here. And then the cosine of whatever side is by itself on the left side, that's the cosine of the angle that you're taking. And so then you're just going to plug in to those values that you know. On this one, we knew all 3 sides. So we knew this side was 7.1, 6.7, and 4.4. And then the 6.7 and 4.4 show up again here. And then this is cosine of t, which in our case, we're just going to put t. We left that out. And then your calculator does the rest. Your calculator is just your tool. So you've got to rely on your algebra. Especially with this one, you can't necessarily put this in your calculator and get the correct answer because this is the unknown right here. So you see me squaring the 7.1, squaring the 6.7, squaring the 4.4, and multiplying these three things together, and you get this. Then you want to add these two together. You're just doing your algebra. You get 64.25. Then you want to subtract, because you're trying to get this term by itself. So we want to subtract the 64.5 from both sides. So it disappears on this side, you're left with just this term. And then this minus the 64.5 right here. We then went over here because your textbook likes to skip this couple steps. So this difference here is the negative 13.84 equals this term here, right here. So if I'm trying to get cosine of t by itself, isn't it being multiplied to 58, negative 58.96? So then we divide both sides by that. So that's how they're coming up with this ratio here. And so, how do we break apart the cosine of t? If I want to find t, how do you break that apart? Yeah, you want to do the inverse cosine of that whole ratio goes in here. So in my calculator, I did inverse cosine, but in here, I put this ratio. This ratio turns out to be approximately this decimal. But remember, on your calculator, you can do the following steps. You can do second, well, you can do second, and then cosine. That gets you that inverse cosine. And then you're going to do second, and then you're going to do answer, which that answer is above the negative sign. And all of this gets you that right there. And so you should end up with the answer of the 76.4 if you're in degrees. So make sure that calculator's in degrees. So know that you had some homework problems that were like that. So then let's look at the last problem, 3. Using the law of cosines to solve a problem. So they give a bunch of interesting information here. You and a friend hike 1.4 miles due west. So here you are, and this is not your path. This is your path right here. So you're going due west in this direction. So this is your first path right there. And so that's 1.4 miles. 1.4 miles. That's what they want you to put there. Then it goes on to say, at the same time, 2 other friends hike 1.9 miles at a heading of south 11 degrees west. That just means, so this is what they're doing. So this would be totally south, in other words, directly south. They instead went 11 degrees to the left of south, and to the left of south is west. So they're going in a southwest direction. And they're going in a southwest direction 11 degrees from the South Pole, so to speak. So this measure right here, that's your 11 degrees. And this is their path, their line of path right there. And it said that they went 1.9 miles. So 1.9 miles, I don't have enough room on their box there to write that in there. So that's 1.9 miles on that blue. And so we're creating this triangle. The question is, how far apart are the two groups? Well, the west and south axis lines, they form a right angle, don't they? Right here. This is due west, this is due south, right there. They form this right angle. If this is 11 degrees here, how do I find that angle right there?
Subtract 11 from 90.
Right. So that's what we're going to do. So I'm going to find this angle here by taking 90 degrees, and I'm going to subtract the 11 degrees from it. And what's 90 minus 11? 79 degrees. So we know that that angle there is 79 degrees. So really what I'm looking at is this triangle where I have 79 degrees. Here I have one side that's 1.4 miles and one side that is 1.9 miles. So isn't that SAS? And their question is, they want to find, to the nearest mile, how far apart are the two groups? Isn't that this distance right here, from here to here, which is this distance right there? And so we're just going to use our law of cosines because I don't have the angle, I don't have the side opposite the angle given. So we're just going to call that side, we're going to follow the pattern, bless you. The side we're trying to find is x squared. And then the two other sides would be the 1.4, that's squared, and we're adding to that the other side 1.9, and that's squared. Then you always subtract 2, and you're going to multiply the two sides that are on the same side, so the 1.4 and the 1.9. And then we multiply it by the cosine of what? The 79 degrees. So then you're going to use your calculator to help you with the math. So we're going to go ahead and we're going to square everything that we can. So the 1.4 squared is 1.96 plus the 1.9 squared is 3.61 minus the 2 times the 1.4 times the 1.9 is 5.32 times the cosine of 79 degrees. Our whole goal is to get this term right now by itself. So if I want to get that term by itself, I need to add these two together. What does that give me? Oh, actually I don't need to do that because I know the cosine is 79. Pardon me. I don't need to know that, right? What is 1.96 plus 3.61? So you get 5.57 minus the 5.32 times this cosine of 79. So here's where on your calculator you can put, if you're using the graphing calculator, you can put all of this in there exactly as you see. So long as you're putting parentheses around that 79, you're good. So you can put it in exactly as you see. But if you're using a scientific calculator, you probably want to find the cosine of 79 degrees first, then multiply it by negative 5.32, and then add these two values to it. Neither here nor there. I'm going to put in here what the cosine of 79 is just so you can check it. It'd be nice if I were in degrees. Well, I was working with pre-calc, which is why I checked it. Good thing I know what I'm doing, right? Maybe. All right, so you should have approximately 1.908. But if I put that whole string in, you should get x squared. Whoops, I don't want that color. You should get x squared is equal to, and we're going out to the nearest tenth, but we're going to use a longer decimal, 4.55489 ... right? How do I find x? Square root. So I want to take the square root of both sides, and we're going to ignore the negative square root because x can't be negative. And so on your calculator, you just have to do seconds, and then you're going to hit the square root key, and then you're going to do seconds, and then you're going to do answer to get your previous answer in there. And then these two together are going to give us our final answer here. So x equals did you get 2.13422 ... Yes? And so if we're going to round that to the nearest tenth, what does it equal? 2.1. And is that in chicken feet?
Yes.
Lollipops?
Chicken heads.
Miles. Chicken heads. All right, so therefore, the two groups are about 2.1 miles apart. right, so then on the last page because we just did that. So we're done. And we're not going to do the lesson check today.